welcome to this special episode of Good Governance and Better Security Leadership Series. My name is Anoop Verma. I am the editor of ETGovernment, which is a vertical of the Economic Times, focused on covering government initiatives and policies. Today, our guest for this special webinar is Mr. B. Shanker Jaiswal. He serves as the Joint Commissioner in Delhi Police. He is a member of the Indian Police Service. He is BTech from IIT Kanpur and MS Research from IIT Delhi. He pursues his interest in cybercrime prevention and detection and use of emerging digital technologies for solving practical policing problems. The topic of today's webinar is Intelligent Traffic Management System. In a detailed presentation, Mr. Jaiswal will explain how an intelligent traffic management system can enable safe transportation and help in limiting and mitigating traffic collisions, fatalities, injuries, and property damage through its advanced technologies and systems. Mr. Jaiswal, welcome to this webinar.
Yeah, good afternoon, Mr. Anoop. Thank you so much for inviting me for this webinar. This topic, Intelligent Traffic Management System, is very important. This not only pertains to law enforcement and traffic management authority, but also to every citizen. Because when we go out of our home and we want to reach a destination, we have maximum interaction with, traffic management. And the motivation for this topic is from common experience. Suppose a road user wants to go to a place which is hardly 4 or 5, junction afar, and in process he has to at times stop at 2 or 3 stoppages, 2 or 3 junctions. So at times it is very frustrating. I am sure many road users may be having this common complaint that why I am asked to stop at every consecutive junction. Many junctions are able to know about each other, so that when I have already stopped at a particular junction, perhaps I should be allowed to have a free ride through the next junction at least. So this is the motivation for this topic. In fact, intelligent traffic management system is the answer for this common complaint. Nowadays, intelligent traffic management system is being adopted by many cities across the world. In India also, this system is being rolled out in many cities. In Delhi Police also, we are in the process of implementing such kind of system. So I'll take you through a brief presentation, and then perhaps thereafter we can answer some questions. Okay. So what are the conventional technologies for traffic management? So we all are aware that nowadays we are adopting technology in big way, and there's a lot of technological input in terms of contactless interface with road users. Earlier times, our traffic policemen used to interact with road users. They used to stop them while they are moving to their destination, and at times it's very inconvenient to road users also. Suppose I am rushing to hospital, and suppose traffic policeman stops me, perhaps it will cause me some annoyance, because many times road users are always in hurry to reach to their destination. Already the traffic congestion is a big problem. So the technology has supported us in terms of contactless interface with road users. So even if somebody is speeding his vehicle, he will not be asked to stop. He will be monitored through remote system, remote sensors, video cameras, speed radar. And if there is some prosecution, or the e-challan mode can be adopted without actually stopping the person on road. So these technology were state of the art when they were launched. Interceptor vehicles used to be placed on roadside so that they can measure the speed of vehicles and do e-challan remotely. Similarly, radar gun for speed checking, vehicle message signboards, also latest technology in terms of when a decade back, when road users used to be advised, used to be educated about the road conditions, and e-challan system when one has to make the payment on the spot itself. So that relieves the road user from the prosecution later on. So then, red line violation detection and overspeed violation detection system, these are all contactless enforcement system. So these technologies also came up, and that was adopted in our city, Delhi also. These systems have already been adopted. Now, today's topic is intelligent traffic management system. So what I'm talking, in last 2-3 slides, these are basically technological, progression towards ITMS, intelligent traffic management system. And the very important technology towards that is traffic junction controller. We all are aware that traffic junctions are electronically managed, but when traffic junctions can be remotely managed, and not just one, but multiple traffic junctions can be managed remotely, then that is a step ahead in terms of technological progression. So earlier, the technology came up like wireless traffic light controller. So that was also technology, state-of-the-art technology when it was launched. But now this technology is not sufficient. We have to think further ahead. Can we manage all the junctions in a city like Delhi simultaneously in such a way that we get the optimal uh, throughput or flow of traffic throughout Delhi, throughout the city. So that is basically the motivation for intelligent traffic management system. So technological path to ITMS, I've been talking just now: red light violation detection, over speed violation detection, stop line violation detection, variable message signboards, radar gun, e-challan, interceptor, body worn cameras, online no entry permission. So these are the technological steps which now are leading us to a comprehensive system called intelligent traffic management system. So ITMS, as I said, these are the important ingredient, but the most important ingredient is adaptive traffic signal control. So adaptive traffic signal control was not something which was existing earlier. We had at best area traffic controller, but not a system which manages all the junctions in a city simultaneously in a comprehensive manner, in an optimal manner. So this is the missing link which was there. And now after we have a TCS, adaptive traffic control system, then perhaps this jigsaw puzzle will be complete and the ITMS system can be realized. So when we talk about ITMS, these are the important technological ingredient: adaptive traffic signal control system, contactless traffic violation detection. I mentioned earlier also, red light violation detection, over speed violation detection, stop line violation detection. These three systems are already in place in city like Delhi and many other cities across India. Then variable message signboards. This is basically for dynamically updating road users about the traffic conditions, about the traffic advisory across the city. Then crowdsourcing of real-time traffic data. This is very important ingredient because now with the emergence of mobile applications and social media, road users are also continuously feeding their experiences on many applications. For example, they are continuously feeding to Google locations, and likewise there are other tools, other applications. Many of them are run by some private agencies. So those crowdsourced data can also be very useful when it comes to intelligent traffic management system. Then traffic command and control and communication. So when I say managing entire all the junctions of a city from a command and control room, then we need to have a command and control system where all the sensor data are received and analyzed, and recommendation for all traffic junctions are communicated. Then we have IP-based PS system, public address system at traffic junctions. Suppose at the command and control, a particular junctions has something specific to be advised, and road users at a particular junctions are to be advised, then they can be communicated through PS system from the command room itself. Then traffic accident detection system, because it's through video camera. If there's some accident, the camera can easily identify through video analytics, and immediately the victim can be rescued, can be taken to hospital without any loss of time. So adaptive traffic control system have the following ingredient. Basically traffic monitoring and control, traffic flow management, anti-theft system, support to public services, parking management, traffic infrastructure management. So typically a junction would look like this. At junction we'll have traffic controller and all the gadgets, all the sensors, cameras, air quality sensor for pollution measurement, for pollution statistics. Then LiDAR. LiDAR is similar to radar. Instead of radio wave, here it is light wave. So LiDAR is very important for knowing the various features at a junction, various physical features, whether it's a vehicle or any other thing at the junction. And then microphone is also there. Then edge computing is also can be provided in sensors, and then radar for speed detection. So all these sensors, they collect data and transmit that data to traffic command and control center. So when we talk about adaptive traffic control system, so the fundamental thing which is the crux of entire ITMS is how to manage three important variables for each junction in a city. Let's say a city has 1,000 junctions. So all junctions, if they are allowed to operate independently, then perhaps the purpose of ITMS will not be achieved. And the complaint of a common road user will remain, because the road user wants that from moving from one junction to another junction, both the junctions should know about each other's condition, and the convenience of the road user should be given the first priority. So I am moving from junction A to junction B, and I have already spent 3 minutes of waiting period at junction A. Then perhaps at junction B, I should not be asked to stay put for another 3 minutes. So if all the junctions can coordinate with each other, then we can recommend the ideal values for junction timing across the city. And the ideal values for junction timings are represented by three key variables. These three key variables are split, cycle, and offset. So from this diagram, you can understand, their intersection 1, intersection 2, and intersection 3. These are the three intersections which are consecutive. And a green band represents free movement. So I can organize these three variables. I'll explain what are these three variables in coming slides. I'll give the definition also. I'll show that slide first. So split is the time of a cycle. A junction, let's say junction has 4 axes, road 1, road 2, road 3, and road 4. These are basically, let's think about a junction which has got 4 roads intersecting at junction. So all the 4 roads, let's call them 1, 2, 3, and 4. So from 1 to this cycle which starts, and when the cycle completes and the traffic is stopped at junction 1, and after completion of cycle, again traffic is stopped at junction 1, then this is called cycle time. So a complete cycle will have each junction given a specific time splits, and that's why another concept called split. How the cycle is split between all the 4 roads. So these are the 2 important variables. Total time is cycle, and split time among all the 4 roads is called split. And another variable called offset, that is the difference of timing between 2 junctions. So once a cycle completes at a particular junction and cycle completes at another junction, there must be some offset. Both cannot be, the difference cannot be 0. Then a road user from junction 1 will have to again stop at junction 2 if the offset is not properly managed. So it is by playing with these 3 variables, cycle, total time at junction, as a time split among all the axes of roads, and the offset, the time difference between 2 junctions. These 3 variables can be played, and not between 2 junctions, but all the junctions of a city. It can be 1,000 such junctions in a city, in a big city. So this becomes a very complex affair computationally, because how do you take a decision? Then what should be the cycle time, what should be the split time, and what should be the offset time per junction? So that is basically based on all that input, which is continuously, communicated by all the sensors at each junction. At each junction, as I said in the previous slide, there are many, sensors, cameras are there, even LiDAR are there, the very modern things, and then radar is there. Then air quality sensors are there. So these data, which is collected at each junction, these are communicated through either fiber optics, or maybe in future it can be communicated through 5G or 6G. And that is received at a command and control system, a command and control center, and their data from all the sensors, all the junctions are analyzed in AI engine, and best results, optimal results are communicated to each junction in real time. And that is continuously updated depending on the scenario, because scenario can also be obtained through crowdsourced data. The actual experiences of road users throughout the city can be continuously learned through online system by crowdsourced data. So that data can also be incorporated in the analytics tool, analytics engine. So this diagram shows that how a road user can move from intersection 1 to intersection 2 to intersection 3 without waiting for any moment, and it can be made continuously. And this is possible. This is possible. It's not that a road user can be allowed to move across multiple junctions without stopping. This is not possible. But the number of stoppages can be reduced drastically. The waiting time can also be reduced drastically. And overall, the average speed of the traffic can be greatly improved if we follow the ATCS, Adaptive Traffic Control System. So here you can see a typical scenario, then what should be the cycle time and what should be the offset time. So you can see at junction 1, the cycle time is 100 seconds, and at junction 2, and the offset between these two is 30 seconds. So this is the one scenario, and that can be dynamically learned through AI engine. Another scenario when cycle and split. So how a cycle can be split between various axes, road number 4 and 8 and road number 2 and 6. The time divided between these two axes can be learned through analytics engine, and we call it split. Another scenario, like a conventional way, it could have been fixed timing for each axis. And that's not a very good proposition, because when things are changing dynamically, road conditions are changing dynamically, road users are continuously sending their experiences dynamically, the traffic density is changing dynamically, because depending on the circumstances, early morning traffic can be heavy, around noon it will be light, again in the evening the traffic will be very heavy. So the conventionally we used to have some fixed kind of template for each different scenario in traffic. Morning time different, another template, one template, afternoon another template, evening some different kind of template. And those templates used to be learned by traffic officers on ground. But again, it cannot be very accurate, because different junctions are not talking to each other electronically. So conventional method in row 1 and row 2, more or less the fixed kind of scenario. But when we have adaptive control, these values of split, cycle, and time and offset can be dynamically changed in real time depending on the traffic conditions. And here the human intervention won't be required. Of course, human intervention at times would be desirable, and that options are always kept. But by and large, traffic of entire city can be managed by AI engine, with overall human supervision. So this is the ATCS, Adaptive Traffic Control System flow diagram. So you can see here all the detectors, all the sensors are continuously sending data to Traffic Command and Control Center. And there is something called reinforcement learning. Reinforcement learning is similar to an autonomous agent. Just to give you a perspective about what is autonomous agent. So autonomous agent, if you think about, for example, Mars landing, where the AI engine was not being supervised by ground control because there was a time lag, and the decision was required to be taken in a split second. So here also there's something called reinforcement learning, a discipline of machine learning and AI. So the command and control system based AI engine will continuously learn from crowdsourced data and also the sensor data, and will keep on modifying the variables in such a way that it gets maximum reward in terms of traffic conditions. Traffic conditions means the average speed of traffic, number of stoppages at each junction, and the waiting period for each user. These are the kind of KPIs we want to improve through ITMS system. So those variables will be maximized by reinforcement learning. There's something called Q learning, a specific algorithm of reinforcement learning. So this is the block diagram. And now the traffic command and control center will look something like this. This is a stock photo which I have used here. But this will look something like this. There will be video wall, there will be workstations where operators will be managing a specific area of the traffic. The AI engine will work itself, but it will require some human supervision also, because at times some specific situation may also arise, and that requires a priority of a particular kind given to particular section of the traffic. So that can be managed. For example, if there is some disaster, so for example, some medical emergency, in that case, a particular kind of template can be activated in particular section of road traffic. So that can be possible only when there is some human intervention, and that's why the supervision is required. And the dashboard will look something like this. This is again a stock photo, but it will look something like this, where all the input data can be seen through visualization, statistical visualization, and alerts of all kinds can be seen. Then security operation, operation center can also be managed from traffic command and control center. What are the benefits? The benefits of adaptive traffic control system, which is the crux, which is the most important ingredient of intelligent traffic management system. So the most important is improved traffic flow. So traffic flow, average traffic flow will improve, and the cost will go down. Cost in terms of fuel cost will go down. Cost to environment will be reduced. The pollution will reduce because the vehicles will not be waiting that much if ATCS is realized. And our vital resource time will also be saved. So that will, of course, add to economy. Our time, which is normally wasted in traffic, will be repurposed for other, economic purposes. Then improved travel time predictability. Now, since we know that how much time the traffic is going to take, so we will not be wasting our time going much ahead of the schedule. So, and then enhanced safety, because one of the important ingredient of ITMS is reduction in accidents, because reduction in accidents can be addressed through improved traffic regulation and improved enforcement, prosecution. So the system will judge itself where accidents are happening more and more. So it will direct more enforcement and more regulation in that area. Even road engineering can also be suggested in those areas. So that is the whole purpose of enhanced safety. And of course, pollution will go down. So that will also add to safety of citizen. And finally, flexible and scalable. So now tomorrow some new junctions are added. The system will immediately scale up to next higher level. So it's that way system is highly flexible. It is also possible to switch to various modes quickly without a lot of preparation. So suppose today in a conventional system we want to operate our traffic in a particular way. Let's say there is some disaster or some medical emergency. In that case, we have to direct all the respective junctions, and that requires some preparation, some coordination. But in this kind of system, when we have ATCS, perhaps that can be done in a split second, because all the junctions are managed centrally. So these are the key performance indices. So throughput of vehicle, number of vehicles will increase. More vehicles can pass through traffic. Average speed of traffic will, of course, improve. Average number of stops will go down per kilometer. Average latency. Latency means how much time an average road user, number of road user has to stop at a particular traffic junction. So that latency, that waiting period will go down. Number of accidents per annum will definitely reduce. It has been tested across the globe. What are the challenges? Challenges are, number one, in our country, we have to develop indigenous technology, because if we rely on foreign-based technology, then the maintenance part will definitely suffer, because we have to be dependent on the OEM for maintenance. And second, the conditions of road is very different in Indian cities compared to Western cities. So the AI-based tool requires a special training on Indian data, data of Indian cities. Then only system will perform optimally. Then a data set for training, of course, is required to be created. Readily such data is not available, so that requires some extra effort. Gestation period will definitely be an important point, because technology in this domain is changing very fast. So we have to have a minimum gestation period for rolling out such project. And then multimodal traffic. In Indian city, the traffic has a very wide spectrum in terms of types of vehicle, unlike Western cities. So that requires another kind of complexity in machine learning algorithm, which is used for optimizing traffic. Then lane violation is a matter of concern in Indian cities, because if lane violations are there, perhaps the system will not function optimally, because it is presumed that road users are following lane discipline. And if they're frequently changing lanes, perhaps system will not function optimally. The performance of system will degrade. And then non-standard number plate, that is another challenge, because when you do enforcement in a contactless manner, perhaps the number plate should be ideal and standard, then only the vehicles can be easily identified. So what are the future for adaptive traffic control? So now tomorrow we know that autonomous vehicles are definitely they are on the horizon. In few years we may have autonomous vehicles. So that will add another challenge, how to incorporate that in intelligent traffic management system. On one hand, it will be pretty easier, because machine can easily talk to AI system automatically. But another challenge would be how to manage machine to machine communication, because ultimately the man behind machine would be always important. So that will be a new challenge. And integration with other components of transportation. For example, in Delhi we have road transport. We also have metro transport. We also have, in future, we will also be having other modes of communication. Buses are also moving on roads. So all the different modes of road transport and other kind of transport, railways, metros, can also be integrated. Suppose on the particular road junction, there is a lot of traffic density. Perhaps the traffic density can be eased if a metro comes to takes extra load in that section. So that can also be dynamically managed if all the modes of transportation are integrated with each other. And there are other IoT devices. As you know, IoT devices are becoming more and more ubiquitous. So perhaps managing IoT devices and ensuring their security is going to be another challenge. And the system gradually is shifting to cloud-based, and AI and machine learning is changing the landscape of technology by leaps and bounds. So these are the future indicators where such kind of system has to adapt very fast. So that's for all, Anoopji, about intelligent traffic management system. I can take any question if you.
Thank you for your very detailed presentations of the technology and the methods and the benefits that can come from this system. So can you please summarize once again how this system can improve the traffic condition on Indian roads?
Yeah. So as I mentioned in my slide here, I just revisit that slide. So as I said, in Indian road conditions, there are some very unique feature. If you see any Western city, most of the time you'll find 2 or 3 or 4 types of vehicles, maybe cars and buses, or maybe some motorcycles. But in Indian condition, you'll find all kinds of vehicle, motorized and non-motorized vehicle. You will find rickshaw also, you'll find bullock cart also, you'll find even elephants also move on Indian roads. It's normally
Yes, I mean, the problem of random parking, cross lane driving that you have already talked about, pedestrian and cattle movement.
yeah.
So
So
those
parking,
things will have to be, I mean, incorporated in the system.
yeah. So parking, as I said, you said, is a very important, variable which I have not talked about so far. Any kind of ITMS cannot function fully with full capacity and full, full possibilities and promises what it supports if we don't manage parking very well. As you know, in Indian cities, parking is still a challenging area because people are parking on roads without much concern for traffic. And parking on road at times affect the traffic so drastically we can't imagine. The simple laminar flow, which is the ideal condition for any traffic movement, is greatly disturbed and it becomes turbulent flow. And the speed of traffic reduces drastically, even if one vehicle is parked on road. So that aspect has to be understood. The dynamics of road traffic, the traffic movement has to be understood. And for that, it requires that planners do focus on this area, how to manage traffic, how to make parking linked to road conditions. And maybe parking pricing policy should also be revisited. It should be designed in such a way that it fits the requirement of road traffic conditions. When the traffic is very heavy, perhaps parking should be made very exorbitant in terms of pricing. When the traffic is light, perhaps at that time the pricing can be reduced. So that is something which can be thought of. And then lane violation is another area which is, as I said, is very challenging, and perhaps that requires a lot of education, lot of awareness. Road users have to come to rise to occasion, because if they want to see the benefits of ITMS in terms of their road experiences, perhaps they also need to contribute. They will have to, of course, follow lane discipline. And non-standard number plate is another challenge, but that again can be managed well because the number plate reader technology has advanced. But still, if somebody is not using numbers properly, it will be difficult to identify the vehicle.
Okay. So India already has some kind of traffic management system, and some cities are using it. So what kind of timeline or technology will it take to upgrade to this ITMS system that you have talked about? Can
Yeah.
we do it quickly? Will it take 6 months, 1 year, or more time?
Yeah, so this rolling out ITMS requires two important things. One is all the field equipments are to be installed. So that itself takes a lot of time because physically those equipments are to be installed at each junction and even road accesses also. Second aspect, second component is software. Software is more or less readily available because whosoever is providing software, their software is already, they are continuously updated and made more and more worthwhile. But testing the software in a particular condition, particular road condition, is something which takes time. So some of the technology which are available, some of the big solution providers, maybe some softwares are already mature in some ideal road condition in Western cities. In Indian condition also, there are some agencies who have done software system, and they have to come to the level of ideal performance which we are looking for. So my point is that both the things can go parallelly. While road equipments, field equipments are being installed, the software can also be tested in a in some kind of controlled atmosphere, in some kind of some sort of piloting can be done, and software can be optimized with multiple tweaking using the Indian cities real life data, and perhaps that over a period of time, after many iteration, the software can mature. So ideally, I feel that minimum 1 year would be required, and if everything is done so well, everything is done expeditious manner, it will take minimum 1 year.
So, this system has already been implemented in some advanced Western countries. So, what kind of improvement has it brought?
Yeah. So this technology was around since 70s. In 70s, intelligent traffic management system was implemented in many cities, particularly in UK, Australia, and Japan. That time the technology which was prevalent at that time was original version of artificial intelligence, and at that time machine learning was not used because machine learning was not around, and it was not very much based on database in the sense, because training on large amount of data, that was not possible those days, because the computation was not so much available, and also communication system which required a lot of bandwidth was also not available those days. But those systems still worked well at that time. But now with the emergence of AI and machine learning, and with the availability of huge amount of sensor data, this ITMS has gone to the next level, and the accuracy and performance has also drastically improved. So that's why this technology ITMS has lot of future, a lot is very promising, and with the availability of data and by continuous efforts, the software matures over the period of time, and it works very well in a particular condition.
India is doing quite well in the field of electronics, software. In production, we are among the top 5 countries as far as the production goes. So, ITS also, we can probably develop the infrastructure. What kind of future do you see for ITS in India, ITMS in India?
Very good question, Anoopji. In fact, I often times I share with my audience that with the emergence of AI and machine learning, the gap between best technology, which many times often we attribute to Western world, the gap between Indian ecosystem and Western world has reduced because of data-driven paradigm. Because now we don't have to model, for example, the traffic conditions. We don't have to model the traffic conditions. Earlier, technology used to model the traffic condition. But now with the availability of huge amount of data, we can learn things from data itself. So it's called data-driven paradigm. It's a black box model. The earlier it was more or less white box model, when you have to model the entire traffic scenario, conditions, and junctions behavior, junctions control. Now we just have to crunch huge amount of data, learn from data the best, how the data can give the best results, and then you, based on that learning, you try to change the variables which is in your control. What are the variables in control? The variables which are in our control is, as I said, split, cycle, and offset. So that variables can be changed per junction basis, and be through such kind of learning method, which is machine learning. We often say machine learning. Based on that, the best variables can be obtained for each junction, and that's why in this data-driven model we can have an edge. As you said that we are the software power, and our software engineers are very smart, and they have been improved. They have already proved their worth, their prowess, and I'm sure that in this domain, in ITMS also, we can achieve the best in the world in terms of ideal system which can work very well in Indian condition.
Are there any changes in policies that government needs to take to enable the faster implementation of ITMS in the country?
Yeah. So as far as the hardware is concerned, field equipments are concerned, of course, the best equipment are available, and also the cost has also reduced because of the mass production, and the camera, LiDAR, radar, their cost over the period of time has reduced, and very good sensors are available. So I think there is no denying the fact that we have to, of course, rely on the best sensors, and government is also aware of this fact. Second thing is software, particularly ATCS, Adaptive Traffic Control System. So here indigenization is very important because, as I said, it's a data-driven model, requires in-house understanding, in-house learning from the experiences, and that perhaps requires testing and validation on Indian road condition data. And if such technology is indigenized, it will, over the period of time, it will mature. And that's why under Make in India, because government is promoting Make in India, we need that Indian companies, startups, they should rise to occasion. They should train their models. They should write algorithms, train their models on Indian road condition data, and try to achieve the best adaptive traffic control system, which not only serve the purpose of Indian ITMS, but it can also be exported to other countries. Indian ITMS experiences, because we have the experience of scale. We have the experience of complexity, which is not available anywhere in the world. As I said, we have multimodal traffic, which is very unique of our country. We have, as I said, lane discipline is something which is challenging, but how to surmount that complexity, how to surmount that limitation, again, that will come through some innovative algorithm, some innovative solution. So when we have a learning of that kind, testing and training ITMS in a most challenging kind of scenario, perhaps our learning will enable us to reach out to other cities across the world and provide solutions for their conditions. So we have a great future in this vertical, in this domain.
Thank you. The way you have described, Mr. Jaiswal, it seems that ITMS will be more of a Make in India kind of enterprise, as and when it is launched. Thank you. Thank you for your detailed presentation.